So today we are doing contest 495 from last week as practice, since it has a hard problem. So let's quickly breeze through the first three problems. So okay, range len is len s plus 1 divided by 2 if si equals s len s minus I minus 1 return I. Okay, that should work. Design event manager. You are given an initial list of events. Each event has unique event ID and priority. Update priority. Active event to new, polls highest. Okay, so this is pretty simple exercise. We need a set, and we need to also have a map which will map us event ID to priority. Right, so let's have like private variables, map int priority, and then set pair int events, and then for auto in events, and then we want to do so priority event 0, event 1. I hope the IDs are unique, and of course there is 10 to 5 of them. And okay, event IDs are unique, refers to an okay, and in total 10 to 5 calls. Okay, and then events push, no, insert E0, E1. Okay, so we update priority in this way. Event erase event ID priority event ID, and then priority event ID new priority, and then EV insert event ID PR event ID, which looks like we do the same, but we updated it in the meantime. And then poll highest, what do we return? Oh, and this should be by priority. And what highest priority? So we want to go from like this. So we erase that, and we no. So we have to erase this. So we put a negative sign so that minimum is actually the maximum. Like this, right? And now to poll the highest, we pick the first one, right? So if empty return -1, otherwise we do int priority is event begin first, and then ev erase ev begin, and then return p. I think that should work. Minus p, of course. Oh, that's weird. So what do we? Priority is 774. Oh, you return the. Oh. stupid. 259. Okay, I mean that's a standard problem where you have a set and also damn, two hard problems. Oh my days. Okay. Okay, so you are given an integer array nums of length n. An integer k is called sortable if k divides n, and you can sort nums in non-decreasing order by following partition into consecutive subarrays of k cyclically. Oh my god, bro, what is it? Okay, so what is the size? 10 to 5. Okay. Okay. I mean, the answer is always at least. No, it's at least 1. Not even that. It has to be sorted for 1. Oh. Okay. So we go through all divisors. I mean, there should be at most square root of divisors, I think. And so basically what I'm thinking, right, is that as we go through the numbers, right, at each position we stop if we collected all the numbers from, like, let's say we have a sorted one underneath, right, and then if at some prefix we have all the numbers that's in the prefix, right, then then that's great. And then for each divisor you just wanna check, like, if, because if it's at prefix 2 and prefix 4, then so we just wanna do that. And then for each of the divisors we wanna try to sorry, I had to cough, so I paused the recording. So yeah, I guess that's it. So a nums a sort n len nums. I probably don't want to do it in Python. Maybe I do. Yeah, we could do it in Python, why not? Okay, so we wanna, so once we have that, we wanna have like mark, or let's call it like, I don't know, oh, by rotation. Oh shit. Oh, I thought of a different thing. That's weird. maybe the trick, like, you know, sometimes when you solve a problem, you need to make an assumption which you don't have to prove, and even if it might sound insane, you have to go for it, because you will lose time by trying to verify or look for something less insane. But I mean, n squared n with 10 to 5, I'm not sure if it will pass on Leetcode. But if for a given k we could verify easily, right? And for that, can we verify each block? I mean, we can, I guess, but I guess let's do it in C++. Vector int sorted equals nums sorted begin sorted end. And then divisor and if times if and if plus plus if n percentage if is 0 and percentage if is 0, then we want to do that trick, right? Then we wanna if let's pretend answer will not overflow, but I mean we don't want wrong submits, so let's do this. And now if check of nums sorted and if, or I guess, or do we have to? No, we will just make an inline lambda then ans plus equals diff. And now if n divided by diff don't equal diff, then ans plus equals n divided by diff. And then we return ans. Okay, now we just have to implement the and check and divided by diff, and now we just implement this. So function bool nothing check. Now it takes one parameter, which is like the divisor, or let's call it k, right? Check is equal to int k. Function check is equal to this int k. This means everything passed by reference to it, I think, at least from the scope of the outer function. Okay, so I times k is less than I plus plus. So that's the first block, or we just start like that. So I is less than n, and I plus equals k. So what we need, I mean, I could compress them. Are they unique? No, not really. They don't say like that. Non-decreasing. I mean, cyclical means. Okay, in two pass we can do it. Or free pass. So first, j is I, j is less than I plus k, j plus plus, right? And we wanna first, what numbers do we have in there? So that's, I mean, technically we could store index, right? So direct map int, but they have multiple indices, so yeah, that sucks. So really nah, that's gonna suck. Let's store counts, right, and then count of nums j plus plus, right, and then it's not should be nums but sorted. And then we do left is k, j plus plus, and also we want to check a cyclic, which let's pretend is this, right? So if count of nums j, then left minus minus, and cent nums j minus minus, else break, so let's say like and can, so bool can true. I'm gonna have to check that, and return can. So if we can partition it for a given k, valid. So we do this, there should also be a can here, because we don't need to iterate. And now if j is smaller than I plus k minus 1, if that's the case, then cyclic, or that's like cent cent decreasing is 0. So if this is the case, then we want to, if nums j plus 1, then if cent decreasing, can is false. What the fuck is that? That's the most disgusting if statement of all time. Okay. Why is there empty check? Let's see. 4 in first case, Oh, but okay, so if left don't equal 0 or not, then we want to do this. Actually, that's wrong. So if then that's this, else then that's plus plus, and then if left don't equal 0, so we don't actually even need this cyclic thing. And if left is not 0, then can false. 3, 0, 3. Let's go. Probably will TLE. Wrong answer. Why you output 3, my brother? Oh my shit. But time-wise it will pass, which is good news. Bad news is it's not rotated. Yeah, that's not a sufficient check to see if it's rotated. Okay, so decreasing index, let's store it. Decreasing index is equal to j. So if can, after all this, then we want to check the decreasing. If can and decreasing index don't equal -1, then we want to do like int j is equal to 0. No, for int j is equal to 0, j is under k, j is under k. -1, so that's int current element is nums j I plus j plus 1, and also I mean that has to be like, nah, wait, int I1 is equal to j plus I plus j plus 1, right? And now if I1 larger than or equal to I plus k, then I1 minus equals k, and then int I2 I1 plus 1, if I2 I plus k, I2 minus equals k, and then nums I1, next nums I2, if current over next, then can false, and here and can, boom. This should work, and even on this, let's see, 0, okay. Let's see if it passes or TLEs. Wrong answer even more times. That's interesting. I1, I2, let's see. Why? What? Oh, because that's like decreasing index plus j, like that. Okay, so that's 3, 0, 3, 0, 3. Okay, let's see if there is no output now. Yep. Let's submit again. Already 2 penalties. That's terrible. TLE. I knew it. not sure how to make this faster, to be honest. Can add some caching of sorts, which will be like unordered map int cache, right? And now I mean, we could get primes. No. Because if it's doable by 2, right? The question is if we have square root, then if we multiply square root by 2, could it technically divide? I don't know. Like 64. Could. Yeah, so we need some sort of a cache. Right, and what this cache will do is, or yeah, it can be a list, right? So int cache or vector int cache. Yeah, 1 doesn't guarantee anything. Actually, it doesn't guarantee anything because no, that's not good. So maybe it's solvable in faster than n squared, and how to do that though? I mean, huge pile of ones. Well, if it's in 1, I mean, of course, if it's sorted, then it's all divisors, but if it's not sorted, right, then if it's cyclic by 3, it cannot be cyclic by 6, because, I mean, it makes sense. Well, let's check if it's bool sorted is sorted nums sorted or with nums equals sorted I. It should be ended with it. And now is sorted or this, and is sorted or this. Let's see. Okay, that was way faster. Okay. Incremental even weight cycle queries. You already know that's gonna be one of those shitty ass algorithms like Bellman-Ford or something, or maybe not. Okay, edges are distinct 10 to 5. Undirected graph with nodes labeled initially no edges. You are also given to the integer array edges where edges between blah 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 weight is 0, 1. Oh, okay. Sum of weights of the edges of every cycle in the resulting graph is even return an integer denoting that are successfully added to the graph. You fucking kidding? What is that dog shit? So my tip in this, what I am thinking is that here I'm going to just assume absolute dog shit, as I said 2 problems ago, or maybe even in the last problem. And I assume, here is what we are gonna do, right? I assume it will work. We add edges with union find, and we keep weights of the components, with weights being the edges inside of the component. When we encounter an edge which connects 2 different components, right, we just add it and we modify the weights. If we add an edge between vertices in same component, we only add it if the new weight will be even. and that's it. I mean, that's my logic. I'm not sure it will work, but I'm guessing it cannot be that hard. I don't know if it will work. I don't know, and I'm not sure if I care. So let's code union find for 1 millionth time, but this time with weights. Vector int parent and size and weight int n and n par n size and 1 weight n, and then we do like iota parent iota parent begin parent and 0, and then something, not sure what, so int n int find int x, if x par x return par x find x int unite int x int y. So we first find the components if x is y. Yeah, whatever. We also have weight, right? So if x is equal to y, they're in the same component. I'm not sure, we just want to unite them, so let's just return 0. And then if size of x, size of y, swap xy, size of x plus equals size of y, way of x plus equals way of I, and then parent of y is x, and then we return 1. So that's union find what we need. And now we go through union find uf with n for auto e. What do we need? Number of edges edit, so int ans in edges, and then we want to do like int x e0, y e1, weight is e2. And now if not unite xy, let's do this. X uf find x and y uf find y. And now so we just skip this step completely. And now if unite if xy, actually I don't even need this, I guess, even though yeah. So if unite xy, then we want to do this. So if we unite them, then we want to do like way of x plus plus, no, plus equals w, right, because that's the leader of the component. Otherwise, if they are not united, then if way uf way, and if uf plus w percentage 2 is equal to 0, then ans plus equals ans plus plus, and uf way x plus plus, I think. Plus equals weight, that's fair. And so that should be UF unite, maybe. 0 edges, wow. Oh, UF like that. So that's weird. So UF way X W. What? United. Let's go. So all of them are united for some reason. What the hell? That's weird. Can't I do union find? Okay, that suddenly fixed it for no reason, but okay. 1 and 2, let's see. Yeah, wrong answer, of course. That was a terrible assumption. 0, 1, 1, 2. 2, 3, and then you do 0, 2, which is a exactly. I have no clue how to solve this. mean, this one is actually tough, I would say. You need some random as assumption. There is an yeah, so that don't work. I mean, I'm not sure how to solve this, so I'm not sure I want to sit behind this for 40 more minutes. Yeah, well, this was a case of a guess where it doesn't work immediately. I wonder how many people solved the last problem, to be honest. Yeah, that's straight up cheating, so not sure about that one, but it took 5 minutes to solve this. Why? Must be something extremely simple, which I'm missing for some reason. I mean, how could you do this? looks like people are doing it very fast. Let's do like page 10. They're doing the last problem way faster, or not really even. I mean, these are real results, and I would be straight up somewhere here with my 4709. I would be too, but yeah, they have 4 problems. Okay, I'm taking it back. Well, let's suffer together on this problem. take a walking break for a little bit. Yeah, let's take a break. Okay, so I might have an idea, which is this. We add an edge if this is way simpler. So we color vertices, right? Because even length cycles, you know, that sounds bipartite, right? Because in bipartite graph each, there was some exercise we had a long time ago, but in bipartite graphs I think every cycle has to be even length. This is even weight. So my idea is to color the vertices with something. Who cares, right? And now if we want to add an edge, right, if that weight of the edge is 1, we actually leave that in. So if we unite them, right, then we put it in because it doesn't break the cycle, right? They actually no. So okay, so my idea was to color, right? Like we start from maintain this fake bipartite coloring where vertices have same color adjacent if there is an edge of weight 0 between them, and different if there is an edge of weight 1 between them, and this condition you check when you are connecting vertices, but only when you are connecting once in cycle. If you are connecting once not in cycle, then let's say I would have a like 0 0, right, one component, and 0 0 another component. If I connect one, right, then if I connect 0, nothing changes because the parity of them doesn't flip. But, and that's a but, one of the components has to flip its colors, because when we add edge between them, right, that's gonna suck. And how can we do this efficiently? We only recolor the smaller half, and this way if we color half of the elements, worst case we color half of the elements, but we can only do this log n times to get all n elements. So if and that's an if, let's do this. Why do I even have a struct for this, bro? So let's do this. We need like parent, or they call it, I call it parent, whatever. It should be leader, but leader n, then it's size n, then it's color n, right? And sizes are 1, leader I is I. And then we also need vector h. And here is what we are doing. So x, y, v, right? And leader x, leader y, that's y. Now if leaders are the same, so lx, ly, auto find x para x para x para x find para x. Okay, and now if they are in the same component, here is what changes. If color color lx, or not really, just color x XOR color y don't equal weight equals weight, then ans plus plus, and we don't do anything. Otherwise leader, no, wait, so if size x, size y, swap xy, and then size x, size y, and then leader of y is x. So that's the union part, and then for the flipping part, well, it's in y now, so we basically call DFS from y and flip all colors in that component. So function DFS int, void int DFS int vertex int parent -1. It should be like that. Function int like that. Color v 1 minus color v for in the watch v if u don't equal p DFS uv. Let's see. Leader, boom. Okay, let's see. Okay, so default parameters don't work in here, don't work in lambda function, so so it's 0, 1. Oh, I forgot to do ans plus plus here. 0, 1 and 1 afterwards. Well, it should be 0 first of all. I'm not sure about that, my brother. Oh, I know why. And then h(x) push back y, hy at h xy, and then in this case we also add the h, so that's like function void int x int y, hx push back y, hy push back x. Still don't work. Now there should be color off depending on the starting weight, so starting color should be should be like weight and color X, something like that, and then in C color V like that. Oh shit. Here int h for const auto u weight XOR C. So if the weight is 0 and color was 1, the color, okay. I think that still works. Why is it? W okay, that looks better. So I mean, let's try this. Well, that sucks. 0, 2, 4, 0. Let's see. Let's run it on third case. So leader X, leader Y, what? Why are they in different components, my brother? Let's see. Something wrong with my union find, I guess. So first 0, 0, and we are connecting 0 to, then we are connecting 1, 0. That is fair. Zero, 1, 2, 3, 4, 1. Case 4. So this is coloring, right? And this one has different, and after flipping, in the FS should be at the very end. So we are in the FS and we go from UV typo. How did half of the test cases pass with that, my brother? What is that? How is it possible, bro? What could be wrong this time? What? What? What the hell, my brother? Stack Overflow. Yeah, let's call it visited, and let's be like visited marker. So this so visited marker is 1 minus this of y, right? And then int this mark visited of v is visited mark, and this mark, no, this of u don't equal this mark. Okay, now I'm doing mental gymnastics because I don't want to reinitialize visit every time. So I just want to reuse it. 2, 3, 4, 2. Oh my days, brother, 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 brother. I'm fucking stupid, bro. Okay. That's 3, 1. Visited you is time's up. Okay. So visited you is, I don't understand this shit, bro. Yeah, I could have like unordered set of visited, but not sure if that would work in O1. Visit is clear, and not viscount you. visit it, maybe like that. Oh, not visited. Let's see. Oh my days. Because I couldn't implement visited. That is ridiculous, my brother. That sucks. Yeah, well, whatever. At least I got all 4. Okay. Let's see. So let's order the problems by question ID or last submitted time, maybe. Yeah. So 1, 2, 3, 4 submissions. Damn, Leetcode slow nowadays. Let's write up a solution from this. So so my title will be simple iteration just check first LCL LCL RCL like that, and then there should be like fraction and half, first and half elements if any of them is equal to the mirrored element. If no match is found, return -1. Since the since the equalities are symmetric, we do not have to check the other half. Right, so ON, since we where n is the size of S, since we just iterate over at most half of the string O1, since we only use a couple of extra variables. I mean, this was nice, to be honest, doing 2 hard problems in a short span. Shame I couldn't figure them out, but I figured them out on my own, so I'm happy with that way more than I could. Oh damn, I mean the last part. I mean, okay, let's see. Going to code, and priorities can be unordered map. I mean, we could do some lazy thing like the extra, but who cares? Let's do solution, and from this, so that's ordered set. We need to store the priorities, the events ordered by priorities, and be able to rewrite a priority of event. We can store pairs of priority event ID in a ordered set with a time complexity of insert slash retrieve o log n. Allows us to find the events with highest priority, but we also need to modify priorities. How to do? Can you think of a way how to do that? Hint. We could access the elements in the set if we know the event. If we know the event's priority, we simply have a map event ID priority, which we use to find current priorities of active events, and which allows us to use all login, find, delete, find operation to remove the old event ID entry in this set, rewrite it with the new priority. O of q log n, where q is the total number of calls to update priority and poll highest. On the technical details, we actually store pairs minus priority event ID, that the first element of the set has the highest actual priority and lowest event ID out of all active events with the same priority, and n is the number of initially active events. We only do O1 insert, find, delete calls for each method, all of which take O. Space complexity is ON since we store all events and their priorities. Okay, so that's for the event manager. Okay, so let's look at submissions. That's quite slow. Let's look at solutions. ON using, ain't no way. Ah, good check. That's a good check. Okay. So it does the same thing, but check is simpler. Way simpler. To the, what the hell? Okay, so this is the solution. I just have large constant factor, and it's also Leetcode. So how do we call this? I don't know, like how do we call this? So divisor iteration, who cares? And yeah, whatever. Beginning for sorted arrays as mentioned in the beginning, but it's asymptotically less than the final. less than the final component. Final. So technically it's all one, since we only use a couple of extra variables. Yeah. Because is sorted is just should be even faster. Yes, okay. That's quite a bit of save. 50, 41, 39 suddenly. Well, now, okay. Boom. Okay. What is this? How did I not notice? Okay, update. Oh my days. Damn, I am completely off. Didn't understand. You will definitely get it now. Oh my god, bro. So XOR UV root, and that's root, so U to V XOR condition for valid cycle. Okay, proof out of my ass, but okay. Oh. Okay. Well, that's easier, I guess. So I don't need this DFS and visited shit. And this graph and this, and that's XOR, right? And then we find them and so we don't need all this crap and even all this crap, and then XOR of LX XORed with XOR of LY XOR weight. Almost. XOR of X, XOR with XOR of see. XOR of X, XOR of Y, XOR of weight. Really? No, that still don't work. So parent X is equal to X, we return that, otherwise root find leader, XRX, XR leader, blah blah, okay. parent. Don't even use sizes. Ain't no way. So that's leader X, and if it's not equal, LX, LY, LX is that. Still doesn't work. Result parent sets find if parent X not X root find parent X XR X XR parent X root. XYV, okay. Parent LX is LY. Then LX is equal to XYV ans plus plus. So was this the problem the entire time, my brother? Yeah, I absolutely didn't realize it. Whatever. But I still want to have it fast, so... Yeah, because this doesn't have union by size, that's why. Size X absolutely nothing. That's crazy. Okay, that's slower. Let's try to submit this, how long it will take. 37 milliseconds. How is that possible, my brother? Nope. Cannot be that this inline function is so slow. No, that doesn't do anything. Something is fundamentally wrong. Okay, at this point I have the same fucking code, bro. Oh my days, it's in this. Now if I even do const auto, I might beat him. Yeah, okay. Bruh. Okay, whatever. I guess. Nice. XOR plus union find. One last question. If I erase size and do this, probably will be slower. It's around the same. Okay, so now since the weights are only 0, 1, a cycle is of even weight if XOR of its weights is 0. Next, we will need to distinguish if the edge connects to components or creates cycles. Hint union find. Finally, when components, we have to potentially flip the we will store the parity of each vertex, and if there is a zero edge between vertices, their parities have to be the same, and if there is an vertices, their parities have to be different. When a new edge comes, and it doesn't connect to components, we can always take it, but we have to update the potentially update the parities of one of the components vertices to match the rule stated in the previous paragraph. note that we should do this on a small most half of note that we should do this on the smaller note that we should do this on the smaller component, which has a size of at most half of the number of vertices of the two components in total. Since in that case we do this operation at most log n times. If we are connecting two vertices from the same component on the other hand, if the XOR their colors have the vertices being connected have to have same we just check their parities with the edge weight as per the condition in the first paragraph. Note that we do not have to flip parities of the entire component, rather use just flip the parity of the leader of the smaller component. So but one thing I don't understand is when I flip the flip the leader. Because flipping the leader, right, like let's say I have like these vertices and then I have these three here and then I have these three and then I connect these two vertices, but by connecting these two the flip action, no, so I connect this and then I connect that, so leaders are this, so I update the color of what, like one with smaller size, so let's say this one, but I check connections for these two colors, but this doesn't have to be flipped. This, if this flips, oh, that's when, because when we have inside of the same component. Not sure why that is the case, but okay. So I had to check with AI why this holds, but turns out I forgot about this. But of the leader of the smaller component, a lazy update, since the parity will end, then just flip the parities when doing defined operation. A lazy update. Okay, fair enough. So time complexity. What is the time complexity? And alpha n if we use number of edges is like m, I think. M alpha n if we use both path compression and union by size/rank for the union find data structure, since for each edge we do O1 of find/union operations on the vertices, and of which there are n and there is m edges. Memory on, since we have to store the leaders, sizes and source of components of vertices of each vertex. Okay, quite neat, not bad. Okay, goodbye.